everyone, this is Shatrupa, and in today's video, we will be looking into some of the TCS and QT coding questions. And before I get started with the questions, I really want you guys to pause the video, look into the question, try answering it yourself. And most importantly, we are going to solve this question in three different languages: C, Python, and Java. If you are using any other language other than these three, I definitely request you to try it yourself because the logic remains the same, nothing changes with the logic. But yeah, just the syntax is the different. Okay, so anyways, we are going to get started with the questions. So I have 8 questions right here for you. Highly recommend you guys to pause them and then try it yourself because these are exactly the previous year questions. So give these questions a try. I'm not going to set any timer or anything like that. I just going to read the question, so explain you and show you the code. I already have the codes written beforehand. All right, so we'll see all of that, but I highly recommend you guys pausing the video and trying it out yourselves. Okay, and if you haven't subscribed to Campusmonk yet, please do that. And we are still running our Sankalp batch. The description has the link to that batch. Please look into that and get yourselves enrolled. We'll have a lot of live classes, a lot of interview sessions, a lot of coding sessions, and a lot more in that. All right. But now, without wasting further time, let's get started with the first question. So this is your first question, which says that Joseph is learning digital logic subject, which will be for his next semester. He usually tries to solve unit assignment problems before the lecture. Today he got one tricky question. Okay. The problem statement is: a positive integer has been given as input. Convert decimal value to binary representation. Toggle all bits of it after the most significant bit, including the most significant bit. Okay, print the positive integer value after toggling all the bits. So basically what you have to do, you are given a positive integer, you have to convert the decimal value to binary representation. How? Toggle all bits, all its bit after the most significant bit, but you're including that significant bit. Okay, and what you have to do, you have to print the positive integer value after toggling all bits. Okay, so first thing is to convert the number to binary and then flip the flip every bit. Okay, why it says toggle? Toggle means you have to flip 0 to 1 and 1 to 0. Okay, so you have to flip these two. All right, and return the result as decimal. Okay, so suppose let's take an example like it's given here. Your what is your input value? Your integer is 10. Correct, this is your integer. Now what is the binary of this integer? It is 1010. Correct, now you have to toggle every bit, so this will become 0 1 0 1. Correct, now what is your final binary that you got over here? You got 0 1 0 1. So what is this number in decimal? This is nothing but 5. So that is your answer. Okay, so how does this work? Basically, what does this toggle mean? Toggle means it's basically XOR of all ones of same length, right? So if you are doing taking this and simply do XOR on 1, okay, you are going to get this value. So technically, what are you doing? You are just doing an XOR with all ones of same length. That's it. It may be any input number, but if you try this approach, you will definitely get to it. All right, so let's move to the code part. Okay, and let's see how we can, of course, code this. So definitely, what you will do, you will import math. Okay, that is the library, and then you'll take an integer input of this, then one left shift of this, and then you're going to just do the XOR operation. That is your k value. So if you just run this and say let's enter 10, this is going to return 5. Similarly, if I have to do this in Java. Okay, so what am I doing? I'm taking my scanner input, I'm assigning an empty string. This number that I've taken as input, if that is not equal to 0, then my binary of that number is basically and plus the bin, whatever your bin value will be. Okay, and your number should basically be right shift of 1. Okay, and accordingly we will replace it and find the argument using the binary function over here. So if you try running this, you run this to 10, so that's going to be 5. Okay, so similarly in C++, if you want to run this, so it should be the same. So I'm going to do 10 and it's going to return me 5. Okay, so it's a very simple question. Now let's move on to the next question. So it says that the airport security official have confiscated several items of the passenger at the security check. All items have been dumped into a huge box which is an array. Each item possesses certain amount of risk like 0, 1 and 2. Here the risk severity of the item represents an array, okay, of n numbers of integer value. The task is to sort them based on their value of risk in the array. The risk value ranges from 0 to 2. That is already given over here, 0, 1 and 2. So suppose there are 7 is the input, the total number of elements. That means there will be 7 places, right? You exactly have. So you have to sort them. So what will be your output? It should be 0, 0, 1, 1, 2, 2. Okay. I'm sorry. There are three zeros. So 0, 0, 1, 1, 2, 2. Okay. This will be the output. Now sorting, wherever you have these three numbers is basically called as the Dutch national flag algorithm. Okay. So sort an array that only has 0, 1 or 2 without using a general sort. Okay. Without using a general sort, that is basically your Dutch national flag algorithm. Okay. How will you work on this? What are you given? You are given this array that is 1, 0, 2, 0, 1, 0, 2. Correct? Now, count. What you have to do, you have to simply count, right? You have to count how many zeros are there. That is 3. How many ones are there? That is 2. And how many twos are there? That is 2 again. Correct? And simply treat them in the same way. So, what is the easiest option? Just count the occurrences of 0, 1, and 2 and then reconstruct the array. Okay, since there are only three possible values, you don't have to do any fancy sorting. Okay, you just need to figure out 0, 1, and 2 and just make sure that this is your low, this is your mid, and this is your high. Okay, and just put them in place like that. Okay, that is all that you have to do. Okay. So it says that your input is 10 and then this is your array. So this is the result. How? In the above example, the input array of size n consisting only 0, 1s and 2s, the output is sorted from 0 to 2 based on the risk severity. Okay, so all you have to do is to sort them. You have to just rearrange them. Okay, and you can, for that, you can just use this DNF. All right, so let's see how we can solve this in the code. Okay, so you have your n as an input and whatever your array input will be, then iterate over the n, okay, all the elements of the array, and you're going to append them in the list or ARR, okay, over here. Then what are you going to do? Then you're going to just sort it. Okay, as simple as that. Okay, so if I run this and say my n is say 7, like we'll take the first example. So this is 1, 0, I guess it was 2, then again 0, 1, 0, 2. Uh, okay, I'm sorry. We think that should come with space. So 1, 0, 2, 0, 1, 0, 2. Yeah. So you have it here 0, 0, 0, 1, 1, 2, 2. Okay. So similarly, if we go ahead and run this, because it is again doing the same thing in the Java code. Okay. So if I enter here as 7, and I'm just going to check scanner int. So I'm going to do 0, sorry, 1, 0, 2, 0, 1, 0, 2. Okay. Let me just expand this and hit enter. So it is again the same result. So we are going to do the same for C++ as well. So if you see, C++ doesn't have anything fancy. It is just that your set of uh, syntax is just different. Okay. So let's run this. Say 7. It was 1, 0, 2, 0. Okay, this is going to give an error. So we'll stop this because there was a pause over there. Okay, so we're going to do 7, then 1, 0, 2, 0, 1, 0, 2. All right, so then that is also sorted in that same order. Okay, so let's now move on to the next question and just take a look. So if you notice one thing, these are very small logical questions that have been asked. Okay, they are not that complicated, but how quickly you can write the code, that is the main task. Okay, so it says a supermarket maintains a pricing format for all its products. Value N is printed on each product. When the scanner reads the value N on the item, the product of all digits in the value N is the price of the item. The task here is to design the software such that the given code of any item N, the product multiplication of all digit of value, should be computed. Okay. So suppose, what does it say? That you're given a number N. Okay, you're given an N. Now multiply all its digits to find the price. Okay, so here your N is 5244. So what will be your product? 2 times 4 times 4. Okay, so this is 10 times this is 16. So your answer is 160. So your output is 160. So what will you do? Run a simple loop. Extract each digit using what? Mod 10. Okay, if you do mod 10, that means it will give you the remainder, right? Every single time it is going to give you the remainder. Okay, now multiply them all and then divide by 10 to move to the next digit. So first you are going to, it will give you this. Okay, so you don't have to do anything, you take that. Then next you have to divide. If you divide, the number will get reduced. Okay, so then you will do again mod, so it will become 4 again. Okay, multiply that, then again divide, so the number will become 52 only. So again do mod, again the number will be 2. Do it divided by 10, the number will be 5. So multiply that. Okay, and that's it. That's your final thing, because you will come out of the loop. Okay, so let's see the code over here. How did we run this code? So it's simple. Okay, so you're just going to start I to n, iterate all over. You're just finding the product. Okay, yeah, your product has to be multiplied by 1, so it returns you the same number. Okay, you cannot do it with 0, it has to be initialized to 1. If you do it 0, it will multiply with 0, everything will become 0. Okay, so let's enter that same number 5244, and it's 160. Okay, so similarly, if we look into here, okay, we are doing the same thing in Java. Okay, your result is assigned to 1, can't be 0. Every time you multiply, find the mod, multiply, you divide that value, so it gets reduced. Okay, so we are going to see if it is giving us that answer. It is. Now moving to the C++ code, so it is technically the same thing. Okay, and we will just take the same value again, and that is 160. Okay, now moving to the next question. So as we move ahead from here, the intensity of the question might just increase slightly. Okay, so let's look into this question. It says that an international roundtable conference will be held in India. Presidents from all over the world representing their respective countries will be attending the conference. The task is to find the possible number of ways to make n members sit around a circular table such that President and Prime Minister of India will sit next to each other. Okay, so that means your input is again just n, that is 4. Okay, that is given here as 4. Okay, what will be your possible ways in which the person can sit? Okay, so what is the logic? Now n people sit in a circular table. Okay, the president and prime minister must sit next to each other, right? So that, and what you need the count the total arrangement, right? That is the entire thing. So you need to do, you need to consider the president and the prime minister as a single unit. Okay, consider this to be one unit. Now, so now what you have to do? Now you have n minus 1 arrangements or units to arrange around the circle. Okay, so the circular arrangement of n minus 1 things is how much? N minus 1 factorial, correct? That is what is given over here. Okay, it is n minus 1 factorial. Okay, but within that unit, president and the prime minister can swap, right? So how many people are president and prime minister? There are two, so they can swap in 2 factorial times, which is however 2. Okay, so what will be your total? How will you calculate your answer? It will be this 2 times n minus 1 factorial. Okay, so if your n is given as 4, then it will be 2 times 4 minus 1 factorial. Okay, so 2 times, that is 3 factorial. So what is your 3 factorial? Your 3 factorial is nothing but 3 times 2 times 1, that is equal to 6, correct? So 2 times 6, that is equal to 12, and that is your answer. Okay, did you get it? The first thing is to consider the president and the prime minister as a single unit. Okay, and remember, so there are two members, they can be arranged in two different ways, right, or two factorial ways. All right, so that is exactly how this question is to be solved. So let's look into the code and try understanding the thing. So first we'll take our n, okay, and how will you calculate your factorial? Now factorial we are not calculating here, but we are assigning. What does this means? We need n plus 1 places, okay, and we'll first initialize all of those n places in that circular place to be all zeros. We haven't started anything, all of the value is 0, okay. But now fact of 0, that means the ARR of 0, that like that way, fact of 0 is set to 1, okay. We are considering them to be a single unit, the president and the prime minister. Now you're going to run this I in the loop of 1 to n plus 1. And how will you calculate your factorial? It will be I minus 1, that is the value that we saw, the n minus 1 thing, okay, whatever that current n value is, okay, times I, okay. And finally, what are you going to print? You have to multiply it by 2. Why? Because president and prime minister can be reiterated in two different ways, right? So that is what you are going to do. So now if my n is 4, it should return 12, okay. So similarly, if I run this, okay, so we are doing the same thing, but remember I'm just considering here it to be a big integer. What if the n value is too big? Okay, so we don't want to run out of space. Okay, so say my n is again 4. Okay, so it's returning 12. And similarly for C++, if we just adding int here, so we'll add int and let's run this. So if I say 4, it should result in 12, correct? So yeah. Now, moving to the next question. Okay, that's the same one. We will go to the next question. Yeah, right here. Okay, so it says that particulate matters are the biggest contributors to Delhi pollution. The main reason behind the increase in concentration of PMs include vehicle. What is PMs? It's the particular matters and not the prime minister. Emission by applying odd even concept of all type of vehicle. The vehicle that with the odd last digit in registration number will be allowed on roads on the odd dates. Those with the even will be allowed on the even dates. Okay. So, given an integer of array A contains the last digit of registration number on n vehicles on the date D, which is also a positive integer, the task is to calculate total fine collected by the traffic police department from the vehicles violating these rules. Okay, note, for violating the rules vehicle would be fined x rupees. Okay, so if we look into this example, it says that on even date only even digit last digit vehicles are allowed, right, and on odd date only vehicles with odd last digit will be allowed, and anyone violating this will pay x rupees. Okay, so you have to find total fine that will be collected. Okay, so now if you see here, your n value is equal to 4, correct. Now your vehicles, that is this array, your vehicles is in the array of 5, 2, 3 and 7, correct. Now what are your dates? Date is 12. Okay, D is equal to 12. That is your date. Okay, and your fine is given as 200. Correct. Now, how many vehicles has violated it? Okay, even digits will be allowed, so that means only this one will be allowed. Okay, all other have violated it. Okay, so how many violation? One violation, two violation, three violation, right? So what will be your amount? Then it will be 3 times 200, that is 600. Okay, so how will you come here achieve this thing? So very simple, you have to just iterate and figure out if the mod of 2 is equal to 0 or not, and you have to check if the date is even or odd. Okay, if we do these two things, we'll be able to calculate it. All right, so now let's look into the code. So what does it say? It says that input n, and you're going to take input of your array and your date as well as your x amount of fine. Okay, so count even or odd. So you have to iterate and see if that value inside the array is divisible by your 2. Okay, then you will increment the count of even, otherwise you will increment the count of odd. Okay, similarly you will do with the date. Okay, so if that date is even is equal to 0, then print 0. Otherwise, you have to multiply it with whatever your x value is. Okay, and similarly for the odd. Let's reconnect this. Okay, so now if we run this, let's enter the first value is of n, that is your number of vehicles. So say we have 4 vehicles. The next one is the array, so let's enter 5, 2, 3, 7. Okay, the next one is your the date, right? So date, let's say it's 12, and uh, oh, okay, it expected 2, so I guess we'll give that a space and do it. So it will be 5, 2, 3, 7, 12. And what will be your x value? Say x is 200. Let's take that. Okay, so the answer is 600. All right. So similarly, if we run this, it is also doing the same thing if you see in Java. So it's basically calculating if it is even or odd, and accordingly will increment, and similarly for the date. So we'll just enter and see 5, 2, 3, 7. That is 12 and say 200. So the answer is 600 as well. Okay. So again, similarly, let's try this for C++. So it's 4, then we have 5, 2, 3, 7, and 12. The number amount of fine was 200. That is also 600. All right. So this is how you basically going to solve these questions. Okay. So this was another example and the constraint. So let's move on to the question number 6. So in this question, it's basically to count subset with the given sum. Okay. The first line of the input, it does not have your, I think the question is incomplete, but I will tell you what the question is trying to do. We'll look into the thing over here directly. So let's read whatever it is here. It says the first line of the input contains integer t denoting the number of test cases, and this is the input instruction. This is not the problem statement. Okay, so let's look over here. Okay, so it says given an array, count how many subset have elements that add up to the target sum. So you have this exactly same question in lead code. Okay, a very very basic 75-day grind question this is, and most of the companies ask you this question. Okay, so what it says that you are given an array. Okay, you are given the array that is this 2, 3, 5, 6, 8, 10. Okay, the sum that you have to figure out is 10. All right, so you basically have to figure out all the possible subsets that will add up to this sum. So it is this, that is 2, 3, 5. Then the other subset is basically your it's given 2 and 8. The other one is 10 itself. So in total how many? 3, and that is your output. Okay. Similarly, now if you must be wondering what is this 2 and 6, so this is nothing but the total number of set that you will give as an input. Okay. So that is that. What is this 6? This is the number of elements present here. This is the number of elements present here. Okay. And this is the sum. Okay. And this is the total number of subset. So this is a classic dynamic programming question. Okay. You build a table of like DPIS that is equal to the number of ways to get the sum using the first I elements. Okay. So this is a very, very classic dynamic programming question. Let's directly look into the code how we can solve this. Okay. So if you think about this question, the way that this question is done is not like in terms of your proper dynamic programming, because you can see I've used a function over here. Okay, so that means I am going to call this function somewhere. Correct. Since I'm going to call this function, this is not classic dynamic programming thing. You can definitely optimize this. This is a DP question, but okay, remember this and try to optimize this yourself. Okay, if you have any doubt with this question, do let me know in the comments. I will definitely reply back with the exact optimized code. Okay, so the first thing is you're going to check while n. So let's start from the basic. Okay, so you're basically taking an input. Okay, while your t is greater than, t is your target, greater than 0, your target must always be greater than 0. You're taking your n, you're taking your arr, you're taking your sum, and you're calling the subset count. So that is right here. Okay, so again you're passing these values and you're checking, and while you check you're just making sure if this condition is true. Okay, And overall, that entire value should be greater than 0. Why? Because your target is greater than 0. Okay. But if you count 0 and you don't find anything that happens like that way, you just simply print that no subset is found. Otherwise, just print the count. Okay. All right. So that is a very simple code that I have written here. But yeah, more or less, you have to do the same thing, but in an optimized way. So the first thing is enter n. So let's enter, say, 6. Now we'll enter the number, all the values. Okay. So we'll enter 2, 3, 5, 6, 8, and 10. Oh, I'm sorry. There is enter, there is enter target over here. So 2, 6. Then we'll do 2, 3, 5, 6, 8, and 10. Okay, then we have ARR. So that is done. And then you have your sum. So let's take the sum to be 10. Okay, so you have 3 as the output. Now, if we take another test case, so where your value, let's say it's 5. Okay, and we'll have 1, 2, 3, 4, and 5. Okay, and your sum, let's call this also 10, and you will have the answer as 3. Okay, so this 2 is basically the number of chains that I want as an output, number of array input that I am taking. That is your first 2. Okay, so now let me run this for the Java thing as well. So Java thing also does the same set of things. It is not different. So let me just expand the screen and let's take this input as 2, say 6. Then we'll have 2, 3, 5, 6, 8, and 10. Okay, and your sum will be 10. So that will give you 3. And for another set, say we'll have 5, and it will be 1, 2, 3, 4, and 5. And let's say our sum should be 10, so that will also give you 3. Okay, and we are going to do the same with C++ and just see. So I'm going to enter two sets. So one having 6 element, that is 2, 3, 5, 6, 8, and 10, and the sum is 10. That's going to give us 3. The next one is going to have 5 elements, and we'll have 1, 2, 3, 4, and 5, and we'll have the input as 10. Okay, so that is working as well. So, in question number 7, it says, for enhancing the book reading, the school distributed storybooks to the students as a part of the Children's Day celebration. To increase the reading habit, the class teacher decided to exchange books every week so that everyone will have a different book to read. She wants to know how many possible exchanges are possible. If they have 4 books and students, the possible exchanges are 9. BI, that is book of I, is the book of the ith student. After exchange, he should get a different book other than B of I. Okay, so it says that B1, B2, B3, B4, this is the first state before the exchange. Okay, so these are the exchange states that we have. Okay, so what you need to do is to find the number of possible exchanges if the books are exchanged, so that every student will receive a different book. Correct. Now it says there's a very good thing that has been provided over here, that your output answer should be in modulo of this. Okay, now suppose your input contains the line, one line with n that indicates the number of books and the number of students. Okay, so like your number of books should be equal to your number of student. It can't be different. Correct, otherwise everyone will not get one book. Now it says that if 4 is your number of books and number of students, and how many arrangements, so n student and each have a book. Okay, so after exchange, no student should get their own book back. Now you have to count the number of ways this can happen, and this is exactly called as a D arrangement. Okay, this is D arrangement. And what is your basic formula of D arrangement? This is a math formula, that is D of n is equal to n minus 1 times D of n minus 1 plus D of n minus 2. Okay, so your base case is basically D of 1 is equal to 0 and D of 2 is equal to 1. This is your base case. Now, if your n is equal to 4, like in this case, then your d of 1 is equal to 0, d of 2 is equal to 1, d of 3 is going to use this formula. Okay, that will be your 3 minus 1 times d of 2, right? N minus 1, that is 2, plus d of 3 minus 2, that is 1. Okay, so it will be 2 times d of 2 plus d of 1. Okay, so it will be 2 times of d of 1 is 1, d of 2 is 1, and d of 1 is 0. So basically it will be 2. Okay, and similarly, if you use that same formula to find d of 4, so 4 minus 1 is 3 times d of n minus 1, that is 4 minus 1, that is 3. Okay, so d of 3 is how much? 2. So you'll have 2 plus d of 4 minus 2, that is 2. So what will be the value? It will be 1. Why did I write 3? This will be 2. I'm sorry. D of 3 and d of 2 is 1, right? So the value will be 3 times 3, that is equal to 9, and that is exactly your answer. So this is the formula. This is called D arrangement. Okay. So when B1 goes to student 2 can either go to student 1. Okay, that is d of n minus 2 case, that reduces the problem, or go to someone else, that case is d of n minus 1 case. So there are n minus 1 choices for the one who gets b1. Okay, that is why we basically have to multiply it. Okay, so we are going to see the solution to this. So definitely it has to be, your mod has to be defined. Okay, a and b are the base cases. Okay, now how you're going to calculate your C and D? So you're taking your input n, and if your n is equal to 1 or it is equal to 2, then you're simply going to print n minus 1. Otherwise, you're going to iter over the entire thing starting from 1 to n. Okay, and you're going to implement that formula. Okay, and if we run this, so what was our n? Say let's take n as 4. Uh, Wait a second. So the output is 44. So did it say the out? No, right? So the sample output should be 9. Okay, so I guess it's somewhere wrong over here. So let's, not sure. Let's just try running this. We need to fix the code. So if I enter 4, yeah, this is correct, right? So in Python, I guess I have to fix it something over there. So right, so this is working as 9. I don't know why this one became 44. Okay, so if you see, it is the same thing. We are doing it as it is. We are taking the same formula, but here I think there's an issue with the cd value. It should be correct, but I don't know why this is giving an incorrect answer. Okay, anyways, if you guys figure out the mistake, do let me know in the comment section. I'm going to definitely acknowledge that. And one more important thing is, if not, I'm going to definitely check this code and put it up as a pinned comment maybe. Okay, and you will get the solution over there. Okay, all right, moving to the next question, the final question that I have. So, this is basically a binary tree question. So it says that you are given a binary tree with n nodes. Each node contains positive integer value. The goal is to find the maximum sum path from the root to any leaf node. However, you need to ensure that the sum of the values along the path is not divisible by the integer k. Okay, so your input is going to be few lines. The first line is the input that contains the integer n, the number of nodes a tree has. Okay, second line is contains n space separated integer representing the value of the node. Third line is it contains n minus 1 pairs like integer u and v representing the edges of the tree. Okay, that is, what are the edges? The tree is rooted at node 1, remember that. Okay, and the fourth line is it contains a single integer k, the divisor. Okay, but remember the question says it should not be divisible by k. Okay, finally what you're going to print is the maximum sum of path from the root to any leaf node such that the sum is not divisible by k. If no such path exists, print -1. Okay, so if we look into this, it is like in a binary tree, you have to basically find all the paths from root to the leaf, and you have to find the path amongst whose sum is not divisible by the integer k that you have taken as the output, and you have to take the print the maximum value. Okay, so how will you do this? So suppose here you have let's take a small example because this is a huge set. So suppose our k is 5. Okay. And suppose you have the values like this, say 3, 4, 8, 2, 1, 6, and 10. Okay. Now, what can be your path 1? It is rooted over here, right? So what can be your path 1? So your path 1 will basically be, say, 3 to 4 to 2. Okay. What are you basically checking is what is the sum? Here the sum is 9. Correct. Okay, let's draw the tree first so you get a clarity. Okay, so the path can be 3, 4, 2. Correct. The sum is this. Now if I divide this by k, that is 5. So that is equal to 4. Like you'll get something. So not divide mod. So that is 4. So which is not divisible by k, right? So that means it's not divisible. You're having a remainder of 4. So now if you change the part to 4, 1. Okay, so you're taking this path. Then your sum is equal to 8. Again, 8 is not divisible. It will have a remainder of 3. Okay. Next is say 3, 8, 6. Like this. 3, 8, 6. Okay. Then your sum, what is your sum? It is 17. Now 17 mod 5, that is also not divisible. You will have 2 as the remainder. So the next one can be 3, 8, 10. Correct. So your sum is 21. If you divide that by 5, your answer will be 1. Right. So none of the paths sum is divisible by the value k, that is 5. So what you need to do, you need to take maximum of all the sum. So you'll take max of 9, 8, 17, and 21. Who's the max? This 21. So your output should be 21. I guess they have just given a wrong input over here and this last thing is the input. So we'll just change the input. That will be 3, 4, 8, 2, 1, 6, and 10. Okay. This will be the input. All right. So I hope that you have understood this. All right. So you can see the output is 21. It says note that the edges case, consider the edge case where no valid path exists. Optimize the solution for large input where n can be as large as 100,000. Okay. So let's look into that question. So we are going to use a DFS because we are doing a depth first search. Why depth first search? Because we are going down the path to calculate the sum. Okay. So we are going to do a DFS and we are going to have a max sum and your current sum will basically be the value of node minus 1, which is already given in the question. Okay. Its leaf should always be true. So now you're going to just iterate over it and you're going to basically check if the sum is divisible by k or not, and that should not be equal to your 0. The remainder should not be equal to 0. It can be any positive but not 0. And finally, you're just going to find out the sum. Okay. So you're going to take n as your input. Okay. And then you're going to take k, that is the number that you're going to divide as an input. And definitely you have these values. Okay. So let's run this. And so I will just refer back here to see what was the first line. N is the number of nodes that the tree has. So the number of nodes here will be 1, 2, 3, 4, 5, 6, 7 nodes. Okay. The next one it says is the values that we need to assign. So it will be 3 space 4, 8, 2, 1, 6, and 10. All right. The next line was, third line is the n minus 1 pairs. That, okay, we need to assign the pairs. So we are going to take the values from here, that is 1, 2, 1, 3. So we'll do 1, 2, 1, 3. Then what do we have? We have 2, 4, 2, 5, 2, 4, 2, 5. And then we have 3, 6, 3, 7, 5. 3, 6, 3, 7. Sorry, 3, 7. Did I miss out on any numbers? It's 10, 1, 2, 1, 3, 2, 4, 2, 5. I guess one number is extra or something like that. So, anyways, we're going to run that and see the the last one is basically your k, and that is 5. So yeah, the output is 21. Okay, so we are going to do the same thing with the Java code as well. So this is your Java code entirely same. So we are going to put in that same numbers. So it will be 7, and then it is basically the list. So it is going to be 3, 4, 8, 2, 1, 6, and 10. Then we have the pairs. So that I'm going to go back here. It's going to be 1, 2, 1, 3, 1, 2, 1, 3, 2, 4, 2, 5. And what do we have here? 2, 4, 2, 5, 3, 6, 3, 7. 3, 6, and 3, 7. And finally, we have our k, that is 5. So the output is 21. Same for the C++. It's the same thing. So we are going to just directly run into the code. So we have 7. Then we have 3, 4, 8, 2, 1, 6, and 10. Right? So we have then the values are, I forgot, it is 1, 2, 1, 3, 1, 2, 1, 3. It is 2, 4, 2, 5, 3, 6, 3, 7, and 5. So that is 21 as well. Okay. So, yeah, that is it for this video. I hope that you have understood the question. The questions aren't that complex if you understand it. And definitely, one suggestion to all of you is learn how to actually work with the input and output. And most importantly, try looking for story based question. And if you have time, the best thing to solve would be grind 75 questions from lead code. That is something you should be looking forward to in these last few days before your exam. All right, I will see you in the next one. Until then, keep learning and thank you.